This conference will now be recorded.
Yes, whether it's audible online. Good afternoon, everyone. Whether it's audible.
Yes, sir.
Yes. So today we are here for discussing about interview preparation, right? So I'll just give a brief introduction about this course. So what is about this interview preparation, right? For a few minutes. Then we'll start with the content of interview preparation, right? So interview preparation is conducted, right, for the candidates who are already gone through the course. So compulsory you should be undergoing any course, then only you can attend this session, or else there is no point in attending it. So you should be knowing the concepts of at least what is a flow, what is synthesis, what is physical design, what are steps in physical design, right? So you should have undergone the course anywhere, even in, not in our institute, in any other institute. If you undergone the course, you can join this session. First thing. Second thing is, right, this interview preparation is mainly meant to discuss many questions which are asked in interviews, but it will not be very elaborated. Means we will not discuss as we done in the course. It's only discussing many questions, right? And even the questions which you have doubts, right? Because you would have undergone some interviews and you were not able to answer, and still you have those questions not answered. So then even you can ask those questions. So third thing is, interview preparation will be done on both weekdays. This is done on both weekdays as well as on it is on weekdays as well as on weekends, right? Both. So weekdays different mentor and weekend different mentor. Weekend I will do and weekdays other mentor will do, right? So I will split this course into 4 weeks. Week 1, week 2, week 3, and week 4. I'll split into 4 weeks. See, this I will not this I will not call it as first week. It's
Oh,
just a demo.
hello.
Uh, Please tell me.
Am I audible, sir?
Yes, yes. Please tell me. Yes. Whether it's not audible from my side.
It's audible, sir.
Yes. Please tell me whether you have any questions. Okay. See, I will split this entire course into 4 weeks. Week 1, week 2, week 3, week 4. So in first week we will discuss about synthesis, right? Inputs files for PD. So in second week we will discuss about floor planning, port placement, and macro placement. Floor planning, port placement, and macro placement. And in week 3 we will discuss about So this we have mentioned as CMOS low power techniques and physical only cells, right? So here only we can even go with multi voltage design and physical only cells. So week 3, we will discuss about power planning and STA. So even power planning also, right? We will discuss here only. Power planning. Port placement, macro placement, multi voltage design, physical only cells, power planning, and STA. So next week 3. So we'll discuss about placement CTS, placement CTS, and routing. So I'm telling this both weekends and weekdays, CTS and routing. And last 4th week, right, we can discuss on sign off checks. And still any questions from students, right, that we can discuss. So this how I will classify. See, this is not the week 1. Week 1 starts from Monday. The end of that week see, the session starts from Monday to Sunday. So the session will be Monday, Tuesday, Wednesday, Thursday. One day it will be a break, and even Saturday and Sunday session continues. Right? So you will be having all the days in a week for discussing all those questions. It will be for 1 month. So we are planning for 4 weeks. 1 week may get extended in case, right? So each day the session will be for 3 hours. We'll take session for 3 hours, right? So Monday, Tuesday, Wednesday, Thursday, right? Our mentor will do, and I will do it on Saturday and Sunday. If you have any queries on the weekdays class, you can ask with me. And even if you still have any other questions apart from this, what we are discussing, so we only frame questions and we only discuss the answers. Apart from that, if you have any questions, you can ask me. The questions which you were not able to answer in your interviews, right? So all those things you can ask me. So the sessions we are conducting for 4 weeks. After 4 weeks, so if you want, we'll take a mock interview to test your ability or your preparation level. When you are ready, and we can give you the suggestions how to improve, right? So this sign off checks also includes, see whatever we are working till today, we have worked under a technology of 28, but we also focus few guidelines of low technology issues, especially during the floor plan creation. What are the low technology issues during the placement? What are the low technology issues? So we'll also discuss few lower technology during routing. What are the lower technology issues? What are how the rules are different from higher technology to lower technology? We'll also discuss that. Right. So these are the see CMOS covering is not possible, right? Because we have the 1 week, 1 month time. See, this is what to cover only this only for us. Time is not sufficient. See, I already told you clearly. This interview preparation course is for the candidates who has undergone the basics and the course, who have undergone the course of physical design and CMOS. Only for them this course is conducted. This interview preparation means how to
Hello, sir.
answer in an interview, what are the questions may be asked, and what are the answers, or the probable answers you may give, and even some questions which you were not able to answer, even ask those questions in interviews.
Hello, sir.
Please tell me. And CMOS
So,
becomes a very basic topic, right? I think we cannot cover them.
hello, sir.
Please tell me. Please tell
So,
me.
can we get the recorded videos for these classes, the interview preparation sessions?
Yes, you will get it. Probably,
Okay.
see, regarding recorded videos, you should talk with the admin. So probably I am recording from my side, and if you want, you can talk to the
Because
admin. We will give you.
we are at the sign-off stage, so we are having labs during weekdays. That's why.
No, I am recording from my side, right? And you can ask the admin that he will give
Okay.
the videos.
Okay, sir.
I think you
Thank you.
can get the videos. I think it will be given if you are requesting. They may give with the valuable reasons, like he told he is doing the lab. Yes, see, I will not send the PDF. Whatever discussion I have done, all notes will be shared for the benefit of the students in the group. I will share after every class whatever we have discussed. Right. So weekdays, I think it is for 4 days. It is for 4 days, and weekend it is for 2 days. So the course starts on weekdays from Monday. The new topic the mentor will discuss for 4 days. In those topics, if you have any doubts, you can ask me on weekend, and even ask your own doubts. And even I will come up with the my whatever which is not discussed in weekdays. I will come up with the questions. I will engage for 6 hours. Means 3 hours on Saturday and 3 days, 3 hours on Sunday. See, first of all, first when I go to the discussion, right? First I will start with what is the expected in an industry, because even I have worked in many levels of interviews. Right? See, in industry, there may not be a only single level of interview. There may happen interview happens in 1 or 2 levels. See, for example, if there is a 10 requirements, if we get 100 resumes, and even we feel 100 resumes are good, then first level of interview will just make to filter the students. So what is the ability they will look in you, right? For a student, what ability they will look in different levels of interview is, in first level of interview, they will just check whether you have done the course properly or not, or you're coming up with any fake things, right? Second thing, they will check mainly, right? What ability in the first level of interview is, so first, what is the ability they will look in you? First, they will look into your flow, whether you know the flow properly or not. See, every person should be knowing what is a flow. See, most of the questions at the beginning will be very straightforward. Explain about your project or explain about the PD flow. Explain ASIC design flow, right? First, they will look whether you know the flow properly or not. And they look for communication, right? So I repeated many times. See, even if I do hundreds of these classes, if you are weak in communication, no one cannot help you. I'll make very clear, even though I've told many times, but still I'm telling. They will look into your communication, how good you are in communication. Because see, later, if any service-based company is hiring you, later they will send you for any product-based company interviews. All right. First thing requirement is your communication skill. So you should be having good communication skill. And next is basics. Right? You should be having good basics. So understanding of concepts. Just understand the concept. That's it, right? What is antenna effect? Whether you understood the concept, they'll check. Basics of FED. Right? It is not required. They will not ask any tricky questions in the first level of interview. Right? Basics of PD means what is antenna effect, what is crosstalk, what are methods to fix it. So they will not ask, you have M5 layer, you have M6 layer. In M6 layer, there is some congestion issue. So you have only M5 layer. What method you use to fix something? These type of questions are not asked. The questions are very straightforward. They'll check the basics of PD. That's good. Or they may ask, explain the lower technology issues. So then, if you are good in this, then they'll start different questions. Right? So what is my suggestion is, you should be knowing the flow properly. What is the flow? PD flow. I think hope everyone knows the PD flow. Flow means it is not like that you will do floor plan placement CTS routing. So even inside floor plan what you will do, inside placement what you will do, inside routing what you will do. Everything you should be knowing. That is a major thing what they will see in you. If flow is correct, and even in that, see, those type of questions are asked only to judge your communication, how you are good, how good you are in communication. So please improve your communication skills, then only you can clear your interviews. I think those who are good in communication and having a better knowledge, they have already cleared the interviews that they have done. And second thing is, right, what I want to discuss in advanced level. So advanced level means it may not be a separate interview. In the same interview, even they may go to some advanced levels. In advanced levels, so even there will be some tricky questions. For example, you are doing ECO stage. Right? You are working in ECO stage. You want to insert some cell in the design. You are working in ECO stage. You want to insert some cell in the design. What are the approaches you will use? So what are the approaches we will do? We want to insert directly. We will insert. No. First check for spare cell, whether there is any spare cell present or not nearby. I think everyone knows what is spare cell, right? First check whether there is a spare cell nearby. For example, if you want to insert buffer, you check whether there is a nearby spare cell available. If spare cell is available, directly utilize the spare cell. If spare cell is not available, then check if you are inserting a buffer, how far it will be placed. Because near to the region where you want to insert the buffer, you may not be having enough space. So if you legalize the buffer, it may go and legalize somewhere else. Right? That may still lead to degradation of timing. Just give me 1 second. See, for example, so if you have a design and you have cells everywhere, right? You have cells everywhere and you want to insert a buffer. You assume you want to insert a buffer. So the net is going like this, right? The net is going like this. It's going very far. To break this net, right? You want to insert buffer somewhere here. That is what your agenda. After routing, if you are inserting a buffer, that is called as ECO. It's called as what? ECO. So what and all things you have to follow? First, check whether nearby any spare cells are there, right? If this is supposed to be a spare cell, or is supposed to be a spare cell, then automatically use the
Hello?
spare cell. Automatically use the spare cell and make the connections. If these nearby spare cells are not available, then look whether you have sufficient space. See, even though you insert the buffer here, right? Even though you are inserting a buffer here, but when this buffer is legalized, it will legalize somewhere far. So again, net length will go like this, it will come like this, and not like this. So you should check whether legalizing can be done nearby. If I insert the real buffer, whether I can do the legalizing nearby. If legalizing is happening nearby, then you insert. If it cannot happen, then don't insert. Then check the connection. So this you are inserting because of net length, right? Check the connection between this cell to this cell to the previous cells. If possible to move this cell somewhere, right? Move it. If there is no timing degradation from here. So these are the steps what you take during ECO, right? So like that, some tricky questions may be asked in the advanced level of physical design. What you will do. So if you want to insert the buffer for hold fixing, where you will insert? Near the capture end, or so you want to insert a buffer to fix hold violation. Where you will insert? You will insert toward launch side or capture side? Any answers?
Capture side. Capture side.
Yes, you have to insert
To
near the capture side, because if you
yeah.
insert near the launch side, there will be some other path forming from this, right? You are fixing hold, but this may degrade the setup. So always insert near the capture end. If you are inserting near the capture end, then this buffer is applicable only for this path. It is not disturbing the other paths. Other path is going like this, right? It's going like this and it's going like this. So here you have few cells, combo cells. So I have 5 violating paths at the end, which is having -2 picosecond, -5 picosecond, -10 picosecond, right? Like this, -3 picosecond, -4 picosecond, right? So whether I can close my design with this?
Depends on the time period, on which time period we are working on.
Okay. So I assume I'll tell that you are working with 500 PS time period. So whatever I do, I cannot fix these violations. Whether I can close the design.
Yeah, we will be documenting this slacks, and for the next iteration, we'll be fixing this.
No, whatever you do, you cannot do it. You cannot fix. If you are further doing anything, these values are degrading still. Then whether we can close your design with these slack values.
Yeah, we will be documenting, and after next for the next version, we will be trying to solve in the starting phase only. Like that, I was.
So your answer can be, right?
Yeah,
There is two possibilities. One, you have more uncertainty, right? In the equation, you have uncertainty value. Uncertainty is used as clock jitter, right? If any clock jitter, it may happen or it may not happen. If this uncertainty value is very huge, like it's almost around 100 ps. So these values, these slacks are nothing compared to what? And means this 100 ps of uncertainty may not happen or may happen or may not happen. We are not sure, but still we are using this uncertainty in the equation. Uncertainty is already used in the equation. If uncertainty is very huge, then these small values can be neglected if at all we don't have any other options. So that can be one of your answer. See, that shows at least, see, for whatever interviewer is having in his mind. So you cannot brain map it. Because for every question, answer, what he expect is, he will expect the answer from his experience for every question. So for that reason, we cannot brain map and we cannot get the answer, what he is thinking, right? Interviewer. For that reason, we cannot quarrel with him. So only thing is we can come up with a probable answer so that at least it should be, see, answering nothing is not the solution. Answering something convincing is a solution. So one of the answer can be, if you don't have any other options to fix, check the uncertainty. If this value is very high, then probably these values can be neglected. Or when these values are, whether if these values, whatever values we are getting, it is, we are getting this values from GBA, right? Graph based analysis, graph based timing analysis. Check with PBA.
analysis.
If with PBA, probably these values may get fixed. Check with that. If these values are with GBA and with PBA, with these values are fixing, then we can close the thing. So here, what I want to tell is, interviewer something he is having in his mind. We are not worried about that. We are coming up with some answers, showcasing you know something. Right? Here, your answers tell you whatever answers you are telling. It is showcasing that you know something to evaluate the timing. Right? You discussed about, okay, if this values were from GBA and if you go with PBA, path based analysis, and if these values are fixing, then you need not to worry. Then you can close your design.
Yes, sir.
So you have crosstalk, right? And you have crosstalk between two cells, right? And you want to fix it. You want to fix this crosstalk. But metal tapeout is already done. If you fix this crosstalk, the timing may reduce. Then how will you fix it? Routing with some other layers is not possible. Only these layers only you should use. How will you reduce the crosstalk? One more. I'm telling that you cannot do anything. Routing you cannot easily modify. Shielding means you have to insert some net in between. Okay, that is one of the option. You can do it during the metal ECO. But what is the methods you will find? Break the net, right? Any one of the net, if it is possible,
Yeah.
break it. If in nearby, if you have spare cell. See, I'm telling we are doing metal ECO. Metal ECO means I cannot insert new cell. During metal ECO means base tape out is already done. And after base tape out means all these cells are sent for what? Fabrication, but only metals are not sent. At that time, I want to fix crosstalk. Then what I should do? Look for spare cells, and if I can break this net with spare cells, even the spare cell is far away also. If you can break this net with spare cells, I'm deviating a little bit. Then, if you can do like this, right, crosstalk will be reduced by huge margin. Right? So break the net by using spare cells. That may reduce the crosstalk. So like these questions, they may ask during the advanced level of physical design for a experienced candidate and even for a fresher. See, for a fresher point of view, even though these questions, if you are not answering, that is okay. But you should answer these questions for sure. See, these questions will be like flow, your communication, basics of PD means explain congestion, how do you fix congestion, methods to fix, what is the macro placement rules. Those questions you should compulsory answer. So advanced level of questions will be very tricky. It is with interviewer, he'll always ask these questions with his experience. Today, one person who is working with 3NM, if he's asking questions, so all his rules, all his strategies, everything will be focused towards what? 3NM. So 3NM and 7NM has more difference. So even we have 2NM, 1.8 NM. Right? Even there are projects which are going with 1.8 NM. So 1.8 NM rules and 3 NM rules are very different. If the interviewer is asking, keeping his experience, and if he is asking the questions, right? So how to tackle, right? Always tackling the interview is not always giving the appropriate answer, correct answer. So you should give answer in such a way that showcasing, you know, the relevant concept. Even though you cannot give the exact answer, but at least showcase that you know the relevant concept. Because interview is not always on the correct answers. Interview is always on the best answers. Out of 10 candidates, who has given the best answer? Because he cannot reject everyone, right? Out of 10. Who has given the best answer? Based on that, we will select the candidate. Even though you are not answering the answer which is in my mind, but you have showcased the relevant concept towards that. So then your interview may get cleared. So always handle the interview. Don't get frightened. Showcase your relevant, right? Showcase the relevant topic or showcase the relevant knowledge towards that question. Even that may clear your interviews. So even though that may not be the right answer, right? So interview, we will discuss few things like this in Saturday and Sunday sessions. So even Monday to Friday, Monday to Thursday, if the normal questions are discussed, and Saturday and Sunday, we will discuss some different tricky questions, even from my side or from your side. All right. So the first topic, what we started from today's session. See, normal topics I will give to you people only. What are the normal questions they ask from interview point, which is apart from the technical concept, is explain about yourself. That is very, very important question. So explain about yourself. You should focus on answering your relevant personal information, like what is your name, which is already known, and from where you are, right? And what is your education? Mainly, education means we have done BTech in electronics and masters in VLSI, and any training, right? Any training you undergone, and you can also tell about your previous experience, internships, anything, right? That should be your experience and internship. So even though this is apart from the thing, right? The first question may be explain about yourself. First explain. So my name is Pratik and I am from Bangalore. Means a short address where you are from. And I have done my masters in VLSI and embedded design, and I have undergone the training in VLSI Guru. And during my training, the training was for 6 months. So just, and if you have done any internship in any reputed companies, even you can mention that. All right. First, it should be about your education, training experience, and internship. Second thing should be your hobbies, interest, right? Third thing should be any achievements you have. Right? Achievements means you are a district level player, a state level player, or you are presented the in any conferences. If you have presented any papers during your UG classes, any new reputed conferences like IEEE conferences, if you have presented and you were some secretary of some forum activities, something, right? So all those things you can mention at the last, showcasing that you are the active player in any of the event. You're not simply sitting, right? It is not none of my thing, right? So you should showcase that you are the active player. So at least explain about. See, if I ask recently also, if I ask explain about yourself, the candidate tell his name. Sometimes he will not tell his education also, and he tell about his family, my father and mother. We don't want that, right? We want only your education. See, we want interviewer wants everything towards his company. What is the advantage for his company, right? Education, training, experience, and internship, and your hobbies. So I'm the person who loves to listen the music always, and I have interest in music. I've learned piano. I'm a good singer. Anything like that, which is, if you have any good hobbies, you can tell that I have interest in reading books, and I have read many books like Rich Dad, Poor Dad, something books you have, right? So those books you can mention. And you can also mention if you have any achievement at the last. And I also have interest. I am also a sports loving person, and I have a good basketball player. And during my graduation, I have participated in the district level basketball competition or something, right? If you have anything, you can mention all those things. So this should be your explain about yourself, which apart from the technical concept. So apart from that, explain ASIC design flow. I think everyone knows about it. I will not reiterate those questions. ASIC design flow, right? And explain about your project, because you mentioned that you have done the training, right? They wanted to know what you have done. Explain about your project. So those type of questions they may ask apart from the technical concepts at the beginning. So these questions are asked mainly to test your communication skills. So you should be good in communication. So second question will be like explain ASIC design flow. Third will be explain about your project. I'll ask Monday other mentor to cover these questions because they are very simple. She can cover it. So these are the questions which are apart from the technical questions, and some questions may be like explain challenges in your project. Challenges during your project. So you cannot tell that there were no challenges as mentor was there, right? You cannot tell that. So you can always go with some challenges like fixing timing in the placement stage was the major challenge because one of the family was having more logic depth. What do you mean by logic depth? Number of cells between two registers. So we had few paths where there were more logic depth. It is called as logic depth. Generally in industry, what we'll do if we have more logic depth, once we try with path grouping, at the first method we try. Logic depth means I have 40 cells here. If and my time period is almost 1 gigahertz. 1 gigahertz means what? 1000 picoseconds. But combo cell, if I have 40 to 50 cells, right? You assume there's a 50 cell, and 50 each cell is producing 20 picosecond delay. That is a minimum delay. We cannot reduce below 20 seconds. Then what happens? 50 cells into 20 picoseconds. How much it is? This itself is 1000 picoseconds. And what about clock to queue delay, uncertainty, setup time? Whatever I do, I cannot meet this path. Only option is I should reduce this logic depth. If you are given the netlist, you cannot reduce the logic depth. If you're working at the level of netlist, you cannot reduce the logic depth. If you're working in the synthesis level, at least you can reduce some of the logic depth. See, one of the option you have in the placement stage to meet this path is whatever cells you are seeing here, right? 50 cells, at least place nearby. So that net delay is what? Net delay is reduced so that each cell delay will become at least 18 picoseconds. Somewhat the total cell delay will reduce. Only one option you have in the placement stage is to place the cells nearby. But you cannot reduce the logic depth for sure. So for to place the cells nearby, all these cells, right? What is the option you have? Path grouping. Path grouping means for those cells which are having more logic depth, give this path higher weightage, right? Give the path what? Higher weightage. And run the placement optimization again. So when you run placement optimization again, these cells, as they have higher weightage to fix timing, they may be placed what? Nearby, so that little bit timing can reduce. That is what the option you have in physical design if the netlist is given. If you are running from the RTL level, which you are responsible for synthesis, then you can enable the app options like auto ungrouping should be enabled, boundary optimization should be enabled, and high timing should be enabled, ratio retiming should be enabled. If you enable all those things, there is a chances of reducing the logic depth. After doing all these things, if still logic depth is not reduced, then you have to inform the RTL engineer to take care. So you can tell that, see, because here you cannot tell RTL engineer in the course side, right? You cannot inform the RTL engineer and all in the course. What the only option you have is, one of the challenges what I have faced is, one of the family of cells was having more logic depth. So logic depth was near to the time period. It was not more than time period, but it was near to time period. So only one option is, I wanted to reduce the cell delay and net delay, so that I want to place cells nearby. So I have tried different iterations of path grouping many times, and the timing was but little bit okay. That is one of the challenges you have faced, right? I can tell challenges. One of the challenges is logic depth issue to fix timing. So solution for this is many iterations of placement optimization was done with path grouping. That is one of the option. Second option is, if you are doing from synthesis level, you can enable few app options and you can run the synthesis. You can tell timing is the most preference and you can do synthesis. Third option is, you can make, see, this logic depth you cannot reduce by any chance. If you, even your RTL engineer is telling, okay, I cannot reduce the logic depth, then if you cannot meet the timing because of logic depth, the only one option you have is run this as a multi-cycle path. So make it as a multi-cycle path. That is the option you have. Last option. But you don't mention all those things, only this mentioning is sufficient, right? Because in companies also we'll face this problem many times. So what will be the second thing? Second challenge. Fixing shorts and opens, right? Fixing shorts and opens. Not opens. Opens may not be a challenge, but fixing shorts. So what was the challenge here? Please tell me.
Yes, I have a question. Uh, do- Yes, sir. He asked what you have done in path grouping and what we have observed and how will I fix, like this question he asked.
So then you should explain, right? Whether we are from, you have undergone the project in our institute.
No, sir, I have completed the training in February 2024.
In VLSI Guru.
Yes,
Okay, whether path grouping is not explained to you at the time,
he is not
that topic only was not done.
not done. Only I know
Yeah,
that is the process, but how can I explain? I don't know.
yeah, we will explain that during the interview preparation, right? So we will
Okay,
explain
okay,
what is path grouping.
okay, sir.
So path grouping is nothing but assigning the weightages to the paths which we cannot fix. So we will tell tool to put more efforts in fixing that. So how to assign the weight, I'll tell you. I will explain. But I need an example for that. I'll take the example and I'll explain. I'll open the tool and I'll explain during the relevant topics of placement stage. Right? I'll explain that. So only path grouping advantages, all right? my tool will give more importance to this path, which is of interest. So we have to assign more weightage for this. So when you assign more weightage, when my tool is fixing this, okay, my tool sees first what my tool will do. These combo cells first replace all these cells to LVT. Even though I am using LVT, my timing is not fixing. Then the next option is place these cells very nearby. First give preference of placement for these cells. So when the placement of these cells is done, then you take care of other cells. So when the cells are placed nearby, the net length reduces. Net length reduces means what happens? Capacitance will reduce. There is a chances of cell delay. If one cell delay reduces by 0.2 picosecond, then 50 cells means how much it is? 100 picosecond, slack will reduce. A small reduction in cell delay will result in huge slack value, huge reduction in slack value, because 50 cells, one cell is having 0.2 picosecond cell delay. 50 into 0.2 is how much? 100 picosecond. So 100 picosecond cell delay will reduce. 0.2 into 50 is how much?
15.
Increase
It is 10 picosecond, right? Yes, 10 picosecond will reduce. Sorry. Yes, I'm giving an example, right? So if the cells are placed nearby, at least some amount of slack may get reduced. That is called as path grouping. That is one of the method. So what is fixing shots? So what are the things you have done fixing shots? So one thing you can directly tell, my routing layers were restricted till M6, right? But on top of macros, SRAM macros, you should be mentioning. See, macros means only SRAM, but interviewer is not working on only SRAM. He may work on SRAM, PLL, some other IPs, right? You should mention on top of SRAM macros, only layers above M5 is allowed, right? On SRAM only I can use what? M5. But my routing layer were restricted till what? M6. See, for example, you have a block and you have macros. So you have made a stacking like this, and the layers should reach these cells. It's very difficult to reach, because to reach these cells, only option you have is go on top of what? Macros and connector. But on top of macros, only what layers you can use? You can use only M6, because M1 to M5 is blocked on top of what? Macros. Only you can use what? M6. Then reaching to this cells is very difficult. You may have shortage of tracks. That may lead to shorts. So that is what I'm mentioning now, right? My routing layer was restricted till M6, means I can use M6. Above M6 I cannot use. But on top of SRAM macros, only above M5 is allowed. So only one layer, that is M6 is used for routing on top of macro, which was difficult to route, which was very difficult to route. Right? So what one of the option you can do is you can first of all shifting to M7 is not a solution. If restriction is M6 means they have done the restriction with some point. See why your chip top will not allow all the layers to you. See, for example, you have layers in your TF file. You can use from M1 to assume that you can use from M1 to M12. But you in your block you are allowed to use only from M1 to M10. Why M11, M10, right? Why M11 and M12 is not allowed for you to use? Why they are
For
restricting?
power, VDD and VSS.
Here also M1 to M8 you are using and M9, M10 you are using for power. Even for power it's not allowed. M11, M12. Why?
Sir, that can be only used by chip top.
Yes, it
Chip
is
top
not
owner
for full
will
chip.
use.
Full chip has to hook the power first of all. He has to hook the power from your block to another block. And if any missing things are there, he has to hook up. He has to connect. See, for example, there is one block and your block and some other person's block. He has to connect a few layers from few connections from here to here. It has to go on top of your block. So he will reserve few layers for this purpose. Right? So here also M7 is restricted means it is used for power planning. You directly don't go and route it in M7. First change the macro placement. Why there is a problem? Because these macros are in the nook and corner, right? Change the macro placement. How do you change? It is not that completely change it. You can make the macro placement like this. You can live in between few channels, right? You can do like this. In between, you can leave big channels, which facilitates in routing. Right? This problem is not seen. Now there is a problem. Easily, all the layers can come in this channel. Correct? In this channel, all the layers can come. So the layers can easily come like this. They can easily connect, or they can come in this way. So between two stacking, leave what? Leave more spacing if you're seeing this issue. See, in industry, I don't know how it is working. I'll make clarify. Industry will not work in one cycle. You will not do physical design in one cycle. You will do physical design many times. See, macro placement minimum you will do 15 to 20 times. That is minimum. It's not you are going to do in only once. In industry, right? We will classify with the number of phases P1, P2, P3. I am using the terminology of Qualcomm, right? P1, P2, P3. Different industry has different terminologies to mention this stages. P1 means early phase. In this early phase, right? You will just come up with your what is the area, block area. Right? Sometimes you yourself may start with creating block area. That depends upon the company. Right? For example, this is a new project and you are handling one block and your chip top doesn't know what should be the area of the block. Then he will ask you only to create the block area. We will tell in the interview, in the classes, that you will get a def file and tickle file for your core area and die area. That happens in the next stages, not in the early stage. In early stage, you should create. Because of that reason, we have discussed all the methods. You use utilization value. What is utilization? 0.7 or 0.6 or 0.5, less than 0.7 only you should use. Create your own core area, die area, do everything in P1 phase. After P1 phase, you will give your block to what? To the chip top. So chip top will see how it fits this block, how it fits in your block. Okay, if this shape is not fitting, he will change the shape of your block. Instead of that, you use this. See, at the P1 phase, quality of result is not important. Simply create a block, just run the flow of physical design. That's it. How many timing is not, see, because in P1 phase, RTL is not correctly freezed. If RTL is not freeze, you will be seeing lot of timing issues. Even timing team will not come up with a timing planning in one day. Timing planning means what should be the clock frequency, where you have to insert the PLL, everything. They will not do it in one day. Even they need some time. Even those things are not ready. That stage is called as what? P1 stage. Just run the PD flow. So one person can handle 4 different blocks at a time. So these things are majorly done by their employees only. That's a full their employees means I can tell the employees of the product based companies, right? They only do this P1. When it comes for P2, right? Your block you will give to the full chip designer. Full chip designer will change the shape of the blocks now according to his requirement. Now you will be getting different shapes. When each time you get different shapes, come up with different macro placement. So at the end of P2 stage, your full chip designer should be freezed your block shape. He cannot further change the block shape. See, minimum he will change 4 times. Minimum it is. Maximum he can change even 10 times also. Because how you are struggling with your macro placement, he will be struggling with the block level integration. So minimum he will change 4 to 5 times your block shape. Right? So as soon as your block shape is changed, you should change your macro placement here. At the end of P2 phase, this shape should be freezed. He cannot change further. And your macro placement should be freezed. So till this point, you can change macro placement any times you want. So minimum 10 to 15 times you should do macro placement. Once your block is freezed, once your macro placement is freezed, then in the P3 stage, only quality of result you will focus. Quality of results means what is the timing, what is the congestion, what is the routing issues, shorts, opens, if you have, whether you have any crosstalk, any antenna effect. All those things you will focus in P3 stage. So this is how it works, right? P1, P2 and P3 stages. This is how the industry works. So in P1 and P2 stages, you can change your macro placement n number of times, but come up with the correct macro placement. In P3, almost it is called a step out stage. So you will focus on quality of results, improving the design. So further change in, and in P3 you cannot tell that, okay, now I cannot accommodate all the cells. Now my utilization is running beyond the limit, means utilization is more than 1. I have more congestion. You cannot tell this in P3 because all those things you should have taken care in what stage? P2 itself. So most of the engineers will directly work from service-based companies in P2 itself. Will not work in P1 because P1 is just creating core area and die area, right? Running randomly, and that the core area and die area you will give to the chip top, and in P2 he will start changing the shapes. That he will start giving to you. With this, you will start doing your physical design. So most of the engineers will start working in P2, and few engineers will work from what? P1. So in P1, you will be seeing lot of issues with RTL, UPF. In P1 stage, most of the time instead of working with physical design, you will be working with what? Communicating to RTL engineer, communicating with UPF. UPF, it will be multi-voltage design, but level shifter will be missing. Isolation cell will be missing in the UPF. So communicating to them, right? What is the issue? So what are the issues you are seeing? Right? Everything you will be involved in most of the time with fixing this only in P1 and creating core area and die area and giving this to your chip top. So chip top will, okay, chip top knows this much area you want, but he will not give the same shape. He will alter the shape according to his requirement and he will give you. So in P2 you have to use his area and you have to do n number of times macro placement. Only macro placement you will not do, right? In every stage you will run from RTL or netlist to routing stage. Complete stages you will run. So minimum here you will run 5 times. Here minimum you will run what? 5 times. 5 to 6 times you will run the physical design complete cycle. In P3 you will run n number of times. Even 10 to 15 times you will run. Complete cycle of physical design. So complete cycle of physical design you will run minimum 10 to 15 times or 20 times in a one project. So there macro placement you will do many times. So all these things issues if you are seeing in the early stage you have to fix it. So that was one of the challenge, right? So only one layer, that is M6, is used for routing on top of macro, which was very difficult to route. And shots was seen. Shots were seen. So macro locations, macro placement was done repeatedly to fix issues. Or macro placement with channel spacing was done to fix issues like this, right? Like this. Instead of placing abutting like this, between one set of macro you will leave what? More spacing. At least you will leave here 25 micrometer spacing. So in this region, instead of applying a soft blockage, what you will apply? You apply a partial blockage here. Partial blockage with 50% of blockage. That was one of the challenge you can explain. So challenges, real challenges you'll understand only if you work. So next, what challenge you will see? Congestion, right? Congestion. So many iterations of macro placement was done to fix congestion. So blindly you cannot tell what iterations you have done. Simply blindly I cannot tell, okay, I have done many iterations of macro placement to fix congestion. So how you have done? Why there was a congestion? So how you fixed it? So all those things you should explain, right? So I was having a block like this, and my output ports were placed here, and I had macro placement till this point, and I have a small spacing here to route all the outputs were routed here, and this region was seeing what huge congestion. The only option was I had to change few macro placement, few macros where should be shifted from here to bottom. So I changed this entire family this side, right? And a few here I had only two macros. These two macros I shifted here, so more area was formed, and there was no issue in connecting to the ports. So like that you have to explain any one or two issues in macro placement. How did you fix the congestion? So when we are doing many iterations of placement optimization was done with path grouping, means here more weightage was given. was given to iBlender family paths as these families were having more logic depth. So one more thing, what you have done, right? So one more thing, what was one of the thing? It may not be even a challenging, right? So planning and creating a voltage area, right? Even that you can mention. You have written the tickle program for that. The tickle program you can explain. Planning and creating voltage area. Even that you can explain. So for example, if you want to create a voltage area, right? In the UPF, there is one power domain. In power domain, there are few cells. For those cells, how much area you have to reserve, right? If you, whether you can create this much area, big voltage area. If this much big voltage area, if you create only this many cells you have, then what happens? These areas are wasted and you are giving less area to what? Less area you are giving to the arco top power domain. Because most of the area of arco top power domain you have snatched it. This power domain is snatched. And if you create very small, you will be having congestion and you will be having cell density issue. Right? You cannot create even very small. If you create very small, by chance, if all cells are fitted, I think, right? You feel that okay, all cells are correctly fitted in the power domain. Whether that is sufficient? No. At the ECO stage, if you want to add any cells in this power domain to fix the timing, then at least there should be some free space, right? Small amount of free space should be there. Or there is a chance that you have created the voltage area in such a way that it is very small. But to accommodate all the cells, this voltage area is not sufficient. So you have to create a voltage area in such a way that what? You have to create a voltage area in such a way that it should occupy all the cells with some 30% or 20% free space. So tickle program was written, right? Tickle program was written to estimate. I have not brought my specs today. Area of cells belonging to power domain. To estimated area, 20% additional area was added. For estimated area, 20% means you have done the utilization, right? You have divided the total area by what? 0.8. So 20% additional area, additional free space was added. Voltage area was planned to so that it edges are on side rows and side columns. So all those things we have done, but people will fail in explaining. So for that reason, we have to conduct one more session called as interview preparation. So this is about the challenges what you have faced. I have mentioned 4 challenges. So because I have restriction time, I cannot. See, I can mention 40 challenges, but I cannot do that because of restriction of time. But you can do at least 10 challenges. You can note down, because every student cannot tell these 4 challenges repeatedly, right? If 4 students are asked to attend the interview and all the 4 students telling the same 4 challenges, is not correct. You mention different challenges according to you, and frame the answers like this. So next question, right? We will. So these are the questions which are related to general, right? General questions. So apart from these questions, so when I start about synthesis, right? First question they may ask, see synthesis when we talk, right? There are 2 types of synthesis. So first I discussed about general questions. These are the general questions which they may ask. So next they will ask about, so you explain about your project. What you will explain? So I'll also forward an ARPA specification to you. First you have to tell your specification about your project. So during my course in VLSI Guru, I have learned about basics of GVM, Unix, Tickle, and basics of CMOS. And during my advanced course, right? If this question is what you learned in VLSI Guru, right? Advanced question, and in the advanced course, so we have learned all the concepts of physical design, and we have done the project on 32 nanometer or 20 nanometer technology with cell count of 32,000, if the macro count of 40. So you first tell the specification. Then you explain the steps. So we started with the input files, understood the input files. Later we started with the floor plan. So we have understood different commands of creating core area and die area, different methods of port placement like individual pin constant, block pin constant, and pin guide method. Later we understood about macro placement guidelines, and we have placed the macros by using auto macro placement. You know what is auto macro placement, right? There's a command method you have, and we also place the macros by using manual method, that is by fly line analysis. Later we have, after that we have created the voltage area, because our design is UPF. Our design was multi-voltage design. We have read the UPF. According to the UPF, we have created the voltage area for the power domain with name PD risk score. After that we have, so I am not telling that we have done floor plan placement like that, right? I am explaining a little bit what we have done internally. After that we have done physical cell placement. So major physical cells are end cap cells and tap cells. So end cap cells were placed at the end of side rows, left and right side of core area. Even you can place at top and bottom of core area, left and right side of macros, top and bottom of macros, and left and right side of voltage area. Top and bottom of voltage area is not required. And physical tap cells were placed inside the core area as per the design rule manual spacing rules. So which was 30 micrometer. And power planning was done efficiently to reduce the IR drop. So we had planned our higher stops in M7 and M8, lower stops were present in M2. M7 and M8 were connecting to M2, M2 was connecting to rails, and macro pins were directly getting power from M7 M8. Or if you have macro rings, macros were getting power from macro rings, macro rings were getting power from M7 and M8. So we have analyzed the PG DRC and PG connectivity, which was clean after the power planning. Then we went with placement with the different app options controlling the placement. After placement, we have checked congestion, max cap, max trans issues. Even we have written some tickle program to fix the max trans and max cap issues automatically. Then we have checked the setup violations. So you can tell this method, right? One of the family also having more logic depth. So we have tried to fix setup violation even by using path grouping method by assigning the higher weightage to the high blender family. So during CTS, we have understood what is a clock tree specification file, contents of clock tree specification file. No need of explaining it. If they specifically ask, you explain. Later, we have done clock tree synthesis. That was a what type of tree? Fishbone clock tree. After clock tree, we have observed the latency, skew. After that, what pulse width violation, setup and hold violations. So we have understood what is useful skew method, how we can use it, can be used to fix setup and hold violations. Then in the routing stage, so we understood that routing has 3 stages. One is global routing, track assignment and detailed routing. After routing, we have analyzed shorts and opens and some DRC issue violations. After fixing DRCs and opens and shorts, we have extracted the RC by using star RC. So we have implemented we analyzed the timing by using prime time, and ECO was sourced back to the ICC2 or implementation tool. And after sourcing ECO, again timing was analyzed with many iterations. This you should completely explain about your project. That is from starting to end I have explained now. So I am not mentioning about your project, right? Because project will vary from student to student. See, I have answered what I have thought. If you ask with some other mentor, he will tell what he has thought. So according to your thoughts, so you should go with explaining about your project, not only telling that, sir, we have worked with the placement, CTS. No. A little bit 1 or 2 words you have to explain. See, CTS, what you have learned. Main thing is what? CTS specification file, right? Which, see, at least you should mention which type of tree you have. See, it is, if you have not built H tree, not an issue. At least you should be knowing what is H tree, because in industry also I will not build H tree, right? Scripts are there to build H tree. No PD engineer will build H tree in industry. But what is the advantage of H tree, you should be knowing. It's okay if you not build H tree, but at least you should be knowing what tree you have built, right? It was fishbone tree. And you know different types of clock tree. Yes. In that famous thing is H tree. What is the advantage? You should be knowing that. So this is about your project, right? So these are the 4 questions which maybe, see, I will share one of the file to you about your project also. What to explain, I'll share that. So even you can use it. Right? And about the challenges, I have mentioned this one. So now we will go with synthesis. So we'll take a break now. After break, we will discuss a few things in synthesis. Right? Then we'll wind up. That is the first topic, right, which we want to start from the upcoming week. So next Monday, Tuesday, Monday, next Saturday, Sunday also I'll discuss on what? Synthesis, which you have doubts. Even in weekdays it is done. If you have doubts, you can ask me in what? Weekends. And some questions which I feel which has to be added, I will add it. So any doubts you have, you can ask me before going to the break. Any doubts? Any other questions were asked apart from technical? We can discuss.
Sir,
Yes, tell me.
sir, how can we define our CTS algorithm, sir?
How
Where
can
we'll
we?
give like CTS, how
Oh,
can we specify or define CTS algorithm?
see, in Fusion compiler or any tool, right? It's not a one word. You cannot in one word. You cannot tell that you are going with multi-voltage. Sorry, multi-source CTS means H3. You have to build it, right? You have to insert the
Yes.
tabs. You have to build it. I'll discuss what to be done when it comes to CTS. Right? I'll discuss how to build. What and all you should do to build a H3. I'll discuss that.
Yeah, okay, sir.
See, it is not like one keyword will build a H3. No, it's not possible. You have to insert the buffers where you have to, those are called as tabs. So tabs has to be inserted where you have to build a H3. Right? That I will discuss when it comes to the CTS, how to insert tabs, what commands you can use to insert that. That I discuss.
Yeah, okay, okay, sir.
See, all the, for example, in our design, I have 5 clocks. For all 5 clocks, I will not build H3. Because H3 will take more power consumption, right? H3 will result in more power consumption. But even though timing is good, it will result in, so for all the 5 clocks, we will not do H3. Only the, which is a critical clock. Critical clock means clock with highest frequency. For that, we will build H3. Okay. Any other doubts?
Yes, sir. So, as you said, like we are doing many iterations. So,
For which
what would
one?
be the like any fixing, sir? Like fixing shorts or congestion or any fixation. You
Hmm.
said that many iterations will be done. So, what would be the like minimum number of months it might consume to complete a design in that case, if many
Means
iterations?
what is the project life cycle? That is what you're asking. What is a
Yeah,
project cycle
minimum.
time?
Yeah, minimum one project if we consider. So,
See, that depends
what would
upon the company. We cannot generalize that. If you take AMD, Intel, they will take 2 years. If you
okay,
take Qualcomm, they will complete in 6 months.
okay,
So it depends up. See, 6 months is the time what we know. But internally, it may take even 8 months, 9 months also. But we are not knowing about that. But it depends upon the company to company. It varies. It is not the standard value. The
okay.
project time will be there. Right? I have
Is
given
it
the
like
example. Right?
okay,
Even
sir.
some projects of AMD will take 3 to 4 years.
3 to 4 years? Okay.
And sometimes even they cancel the project in between many times. That is also there. So they will hold the engineers and the project will run. They'll cancel in between. And again they'll restart after some time. That is also possible. So that is not the thing. See, it varies from company to company. Some companies will do run for 2 years. So Qualcomm will run for 6 months. Samsung 6 to 7 months. So that is there.
Okay, so it depends totally on the design complexity you're saying, right?
Design
Okay.
complexity, resources also,
Okay.
and importance of the project, right? Also,
Mhm.
some project they will be doing if even though it is not sure they'll implement or not. They'll be still doing, because if the time comes, if they're asking, that should be ready, right?
Okay.
So like that, projects are also going on. For that reason, for those project, ET is not important. They'll run for 2 years. After 1 year, they may cancel also those projects.
Okay.
So
Okay.
see, project time is Qualcomm and Samsung. They will complete their project for sure. Even recently, Samsung has cancelled many projects in between. So if you take that Qualcomm timeline, it is 6 months.
Okay, sir. Okay, sir. Thank you.
It is minimum 6 months. Sometimes it may not be completed in 6 months because it may take even more than 8 months. See, GPDK, general PDK, right? So I think general PDK is not mapped to any technology. So NDM, otherwise you are not used any synopsis tools. Whether you can discuss with the audio. So GPDK, I'm not sure because physical design will not work. GPDK means it's not mapped to any technology. Right? It's general PDK. So general PDK, some EDI vendors will give, like Innovus. They'll give GPDK files because it is not mapped to any it is not mapped to any technology like TSMC, Intel, Samsung. Right? It's not mapped to any foundries. These are general PDKs just to make a practice or practice run. NDM is nowhere related to GPDK. So NDM is a methodology to load the design to the tool. So NDM, so if you take Innovus, right, you will give all the inputs separately. Left file you load separately. .lib you will load in the MCMM, and .v you will load separately. Right, that QRC file. Here we call TLU plus. There you may call cap table or QRC. You will load separately, right? But NDM is not like that. MDM means for HVT NDM. For example, I am taking HVT.NDM. Means here all the dot libs of HVT cells plus dot left of HVT cells plus TF file, because left cannot be understood without TF file. Right? TF file plus GDS. So all these three we will compile. Compile means we will combine and we'll convert to binary. Compilation is converting to what? Binary. Combine all these files, convert to binary to form NDM. So this is the method used in Synopsys. So Synopsys will not read these files independently. So all these files are compiled to form NDM. Synopsys tools will understand only NDM. So similarly, if you want to create LVT NDM, so then you should compile these files to form NDMs. Yes, you got it? This LVT.NDM. So .lib related to NDM, LVT cells. .left related to LVT cells. TF file. TF file is common for all the cells. And GDS related to LVT cells. All right. Combine and compile it to form LVT NDM. For Synopsys tools, we will not give these files independently. We will directly give what? HVT NDM and LVT NDM. That is how the Synopsys tools will work. So NDM stands for New Data Model. So earlier Synopsys was using Milky Way. Now they are using NDMs.
Sir, what is tech.ndms?
What is
Tech.ndms.
tech.ndm? See, tech.ndm is an optional thing. So we have formed it. So this has TF file .tf plus TLU plus. That is tech.indium. It is having only TLE plus information, parasitic information. Instead of that, I can call parasitic indium it is.
Okay, okay. Okay, sir.
Okay, we'll take a break. Now time is 3:45. We'll take break till 15 minutes, then we'll come back. Till 4 o'clock, we'll take a break, then we'll come back. Okay, we'll continue. So when I come to synthesis, right? So first question will be, what is synthesis? Okay, first I'll make the questions, right? What are inputs for synthesis? Third thing, logic synthesis versus physical aware synthesis. Fourth, inputs for physical aware synthesis. Fifth is outputs of synthesis. Of synthesis. Sixth is so what is auto ungrouping? Auto ungrouping, boundary optimization, register retiming, logical restructuring, seventh question will be, what are all the what is wire load model and why it is used? So here also registers optimization, registers optimization. What is wire load model and why it is used? So any other questions related to synthesis? So here we can add, right, steps in logical synthesis, steps in physical aware synthesis, steps in logical synthesis. Fifth is steps in physical aware synthesis. Next is fusion compiler flow in physical aware synthesis. So some part of HDC also will cover here, right? 4, 5, 6, 7, 8, 9, 10, right? We'll also cover some part of HDC. So what are different SDC commands and different types of clocks in design, right? In different HDC commands only I will cover what is set input delay, what is set output delay, what is set load, what is set uncertainty, all those things I will cover here. So anything apart from this questions we have. So what is target library and link library, right? Very important question related to synthesis. What is target library and link library? Next is so what is GTech library and designware library? 15th why UPF flow, right, or multi-voltage design flow, MV design flow during synthesis. So if we have multi-voltage design, what happens during synthesis? So level shifters, retention cells, isolation cells are inserted during what? During the synthesis stage itself. So multi-voltage design during synthesis. Next, any other questions you have?
RTL and gate level netlist.
Okay, difference between whether this question is asked to anyone or whom it is asked. Who has asked?
In mock
clear?
interviews.
RTL and gate level netlist. Next.
Interpolation and extrapolation.
So I think it is not required that we can discuss during the library synthesis, or it is not required. But okay, what is interpolation and extrapolation? Because that this tool is doing, we are not doing anything, right? Interpolation and extrapolation. So these things will be discussed during the next week, right? right, regarding synthesis. And we will also discuss about input files. So what we'll discuss about input files? I think we can also go with timing fixing method, timing equations, setup and hold equation, setup equation during synthesis. Why hold check is not done? Right? Why hold check is not done? Not done till CTS. So here only we add two things, right? One is HVT, RVT. Already you know this difference, right? LVT and ULVT. Industry will also see ULVT cell.
ULVT.
21 is cells with different drive strength. Difference between. See, I am not going to discuss this. This will be discussed in the next class from Monday. So if anything apart from this, if you want to ask, you can ask on next Saturday and Sunday. And I will add few questions on top of this, which is not straightforward, which is very tricky. Right? It depends upon you have to dynamically handle it. Right? Those questions I'll ask. So I'll tell how to answer it also. So if any of these questions are unanswered, then I'll discuss. So cells with a different drive strength. So input files, right? So first question is, first discuss all input files for physical design. So next is input files covers everything. .lib, ts, everything, right? What is .db? How it is different from .lib? Third, it is what is .db, ccs, .lib and what is that? NLDM.lib. So how both are different? Fourth one is difference between GDS and LEF. What are contents of LEF? It's already present, right? What symmetry, right? What symmetry is allowed for standard cells? So what symmetry means what? What is meant by symmetry? Symmetry means, see, for example, I have a cell, right? Standard cell. If I have a layout of a cell, so this is a cell layout. And this cell layout, this is a normal orientation of cell. This normal orientation of cell is called as what? R naught. If you can rotate this cell, right? If you rotate this cell like this, right side, then this cell will become like this. This orientation is called as what? R90. If you rotate left side, you have different orientation again. If you flip on x-axis means this is x-axis. If you flip on x-axis, Flipping means what? This will go up and this will come down. So the cell will look like this. So this cell is flipped, right? This is called as what? MX. Flip on y-axis. Y-axis means this side will go this side and this side will come right side. That is called as flipping on y-axis. This is y-axis. So this is the cell. So this is called as MY. So which orientation is allowed for standard cells? Whether we can use R90? R90 can actually, you can use MX and MY. It's allowed.
No, sir.
MX and MY can be used. But R90 is not used because every standard cell should be present on site rows, right? Like this. So height of a standard cell is always what? It's always present on what? Site rows. If you flip this cell bottom to top, any problem? No, because height of the cell remains what? Same. If you flip left to right or right to left, like MY, no problem because height of the cell remains same. But if you rotate right, one side will be touching at the bottom, but at the top side not be touching. So rotation is not allowed, but only MX or MY is allowed. That too sometimes MY is not allowed. Flipping is allowed, rotating is not allowed. So that is called as what symmetry is allowed for standard cells. So this information is found in which cell?
Dot left.
What symmetry is allowed for standard cells? And symmetry information. See, this question is asked recently to one student. Symmetry information, Samsung interview. This is asked. Symmetry information is found in which cell, which file? Cell delay depends on what parameters? Setup time and hold time of sequential cells depends on what factors and present in which file? Which file? What is def file? So contents of def file and contents of def file. How it is different from left? See why def is used? What is def? Can anyone tell me? So I will discuss every
Design
question.
exchange.
One of our mentors will discuss, or I will discuss next week, right? So the assigning mentors, they will tell you at what time you have class from tomorrow, or see tomorrow there is no class. You have class from what? Monday. From next week you will be having on both Saturday and Sundays. So Just I am mentioning what type of questions we cover. So these are not simple questions we cover. And even you have any questions, you can ask me. So what is def, first of all? So
Design exchange format.
why we use def?
If you want to
Why we have to
give
exchange design?
our design or database to other person, that time we are using this def file.
See, def file is mainly, for example, I am doing a power planning or I am doing a floor planning by using Synopsys tool. And some of the person should use my design and he is also using Synopsys tool. Then using def is not required. He can directly use my block. He can directly copy my block. From the lib, we can directly copy the blocks. But def is, see, for example, if we are doing physical aware synthesis, I want to do physical aware synthesis by using Fusion compiler tool, that is from Synopsys. I want floor plan, but floor plan is done by using Innovus tool, that is from Cadence. Floor plan of Innovus, I want to use in Fusion compiler, that is Synopsys tools. Then the data saving format of Cadence is different. Data saving format of Synopsys is different. I cannot use data from Cadence directly. At the time we use what? Def file. To exchange the design from one tool to another tool. Mainly we use def. For example, you want to use your physical information. Mainly def is used for physical information. If you want to use your physical information of physical design, which is done in Fusion compiler or ICC2, to the prime time. Prime time, if you want to give physical information. I think for the recent batch they have done physical aware prime time, right? While doing, you are given the layout of your prime time. You can directly give the block. You need to give the def file. For example, if you have done the physical design by using Innovus, but timing you are fixing by prime time. Then physical information, if you want to give, then you have to give in form of what? Def. So def is mainly used to exchange the design between two different tools. So def is a IEEE standard format. If I write def in Innovus or if I write in def in Synopsys, the format remains same. The syntax remains same. So def is IEEE format. So if you are exchanging the design between two different tools, then we use def. So any other questions?
Yes, sir. What is the need of sanity checks before the import design?
Yes, right. Import design sanity checks. Good question, right? Import design sanity checks. Next, 10th one is what is NDM format? How data is loaded? How data is import design is done to Synopsys tool. That is about NDM. Okay, I think only these questions are there. So, what is content of each input file? We will cover in what? All content of all input files in physical design. Content of all input files. Physical design. So what is GDS2? So difference between GDS and LEF. Here only we cover what is GDS. So I don't want to make simply more questions are visible, right? Just here only we cover what is content of CTS. We'll explain only. So one thing I can make clear differentiation, like just if they ask question, what is
Difference between flat and hierarchical, sir.
yes, good, right? That is very important. Difference between flat and hierarchical netlist. So which team? I think it's not required. That is not no one will ask that.
What is the need of timing checks after the floor plan?
What is the need of?
Timing checks, sir. What is the need of timing checks after the floor plan?
So floor plan is not yet done, right? But you are telling after there is zero timing check we do. I think we'll discuss during the floor plan only. So only I'm mentioning for
Okay.
input files, right? Anything related to input files, you can tell me. Setup and hold time for sequential cells. I have mentioned here because it is present in which file, right? Many students doesn't know it's present in which file. So I want to know which file, ma'am? Oh yeah. Setup and hold time. It depends on what parameters. So that's it for everyone. Okay, so these are the questions we will cover for next week, upcoming week.
Difference between NAM
So
and
almost it
NAM.
is 32 questions. So any other questions, if you want to add, you can add even in the next weekend, right? So this will be
Hello,
covered from this week.
sir.
Yes,
One doubt,
please tell me.
sir. Regarding sandy checks after import design, we will do sandy checks for check design or check timing, right?
Yes, import design
Yeah,
sanity checks.
but
Yes, correct.
yeah, but that .v file we are not that we are not making any changes, right? It is directly coming from synthesis system. So why are we going to make the sandy checks again?
If you find mistakes, right, then you can inform to those things.
Okay.
So that is a
But
general
already they
procedure.
will. Okay.
See, even though they have done, that is a general procedure. The flow will have that doing the general checks
Okay.
for RTL. So, for example, if there is a assign command, you assume that there is a assign command inside the your RTL. Sorry, netlist. In netlist, you have assign command, and your synthesis team has not noticed that. That is completely forward to you. So, assign command will map to what cell?
Okay.
How it will make the connection physically, right? There is a problem there. Even though for him it may be,
Yeah.
even for him it is not a problem. For us it is a problem, right?
Yeah.
And now when you are having cells like this, when you are having one cell, it is driven from multiple cells. Different pins it is okay. Same pin. Same pin, this A pin is
Yeah.
connecting to output of this and output of this. So this type of multi-driven things are there. Then there is a confusion whether I should take output from this or output from this. This is called as multi-driven. Then we will face problem in some other LEC check somewhere, right? So those things should be cleared.
Yeah.
Even though if they are noticed, then it is fine. If they are not noticed, we have to notice it. We have to tell them. I think generally it will be
Okay.
clean.
Yeah.
Generally, see, every error we need not to mention them. There are few errors you can be ignoring, like undriven inputs,
Okay.
inputs connecting to logic 0, logic 1. Those things is fine because it will connect to tie cells.
Okay.
Every error will not
Thank
mention, but anything like assign commands are there somewhere because that, see, you will be having netlist hundred thousands, 10,000s of line. You cannot find wherever I am having assigned commands or wherever there is a multi-driven nets or any inputs are floating or any inputs are connecting to logic 0. All those things just to check. If inputs are connecting to logic
Yeah.
0, logic 1, you need to mention them. You need to tag them for that reason. That is okay. So few things it are okay, which are okay, fine. But you should be noted that.
Okay. Okay, sir.
Yes, I think I have mentioned that other. I think I have mentioned. So what is CCS? CCS stands for Composite Current Source Model. NDM stands for Non-Linear Delay Model. CCS model is more accurate compared to what? NLDM. See, one more very, very important thing, right? 12th one. What is okay, that will take it in STA. What is flat T rate, AOCV and POCV? What is different? That will take during the STA because D rate has to be discussed for that. We'll do that. So any other volunteer questions you have, you can ask me. Apart this will be discussed in the next week. Apart from that, if you have anything, you can ask me. Any other questions you have?
Yes, sir. Difference between cell view and frame view, sir.
Difference between
Cell view
frame view.
and frame view.
Frame view, I am able to hear. What is another view? Cell view.
Cell view and frame view, sir.
Okay, that is very good question. What is difference between cell view and frame view? So difference between cell view and frame view. Okay, what are the inputs for each step of PD? I think that is not required. That's already, that we'll discuss when we go to each step. What are the inputs? But in one more question, if we have max cap, max trans, and max fan out violation after placement stage, which violations we fix first order wise and why they needed to be fixed? So first we fix max fan out, right? Max fan out should be less than the limit. So if max fan out is fixed, right, automatically max trans and max cap will fix by default. If max fan out is more, automatically max trans and max cap will be more because of max fan out, you will see more pin capacitance. Now, before doing placement step, if you check any cell delay, whether you have checked or not, I don't know. You see how much huge violation you will see, right? Before doing placement, you please check what is cell delay, or I'll show you. So first is my tool will first fix max fan out. It will reduce the fan out. If I reduce the fan out, automatically max trans and max cap will come down. So first is max fan out. Second is max trans. Because what is max trans? So you have output transition more than the limit. If the limit is if the limit is 1.8 nanosecond, the first is max fan out, next you can fix max tran, next you can fix max cap. If the limit is 1.8 nanosecond, but if this is 2 nanosecond, then you are violating by how much? Then you are violating by 0.2. So what you will do now? Now you will upsize this cell, right? Upsizing will, what it will do, if you upsize the cell from x2 to x4, automatically this output transition will what? Reduce. And also its cap limit increases. For example, here cap limit is 8 Fermi-Farad. This can drive only 8 Fermi-Farad, but this can drive 16 Fermi-Farad. So here, for example, there was 12 Fermi-Farad. So earlier, if I use x2, limit is 8 Fermi-Farad. What is actual capacitance? 12 Fermi-Farad. So actual is more than what? 8. Even this is violating cap and trans. So for fixing trans, what I will do? I will change this cell to higher drive strength. Now I made x4. As soon as I made x4, automatically this drive strength also will increase. It will also indirectly fix the max cap also. So remaining whatever the max cap you have, you can fix it. So first you have to fix max fan out. Next is max trans. Next you'll fix max cap. That is order. So even that question was not related to this stage, but I just discussed it. So whether you told this question, whether they accepted this answer, whether you have told in interview. Now there is a hold violation, right? Max trans setup hold. That is the same order. Max fan out, max trans, max cap. So in order of fixing max cap, max trans, max fan out, right, automatically setup is indirectly fixed. So what is PTM model? I'm not sure what is PTM model. Related to what? Oh, this is okay. That is what I told. So max trans, max cap, max fan out setup and hold, right? So this order we'll fix. Even this is the order maintained by prime time also. Even prime time also will suggest same order. What is predictive technology model? I don't know. What is that? I think this model, I think we will not use. Search in internet video. Whether this question they asked in interview, predictive technology model. I think this is not with respect to I think physical design. I think it is with respect to circuit simulation. No, that is not related to physical design, right? Leave it. That is a model. MOSFET model, I think. I think that is with respect to the front full custom design, I think. So synthesis flow we will discuss. So synthesis flow anyhow we will discuss. Synthesis flow is read RTL, elaborate, read HDC, mapping and optimization. We will discuss during synthesis phase. Okay, then I'll stop here. So see, tomorrow there is no class. That's informed, right? Tomorrow there is no class. So the class will start from Monday, discussing all these questions. Right? First week we will discuss. The first week agenda is to discuss on synthesis and input file. So I have noted the questions. So these questions will be discussed from our mentor. Weekend, Saturday and Sunday, I'll discuss on the same topic, synthesis and same input files, any other thing which you have doubts and which I feel something to be added to this and which is not discussed during the session timing, I will discuss. And next week, next week, right, second week, we will discuss on floor planning, port placement, macro placement, multi-voltage, and at the end, again I'll discuss your queries. Right? See, my suggestion is even the questions you feel, see, because the if you feel that it's already known, please attend. Right? And especially in the weekends, you discuss whatever the queries you have related to that topic. Right? Don't ask the question of routing when I am discussing placement. Please avoid because we'll miss the flow. But placement related questions you can ask during placement. Floor plan related questions you can ask during floor plan. Any questions is allowed. You can pick the questions and you can discuss with me in the weekend sessions. So anyhow, I'll share this file and you can continue from Monday. Thank you.